Hello and welcome to this video on number theory. This video is going to be the fourth video in the series which will deal with pigeonhole principle. In this video we will see what's the pigeonhole principle, what does it mean to us, what is the generalized pigeonhole principle, how we can apply the pigeonhole principle, which is going to be one of those in the counting principles for solving problems of real time. Okay, so we will move on quickly into the theorem. So first, what is meant by pigeonhole principle? The statement goes like this. If there are going to be n pigeons which are going to be accommodated in m pigeonholes, and we have that n is going to be greater than m, that is, we have the number of pigeons to be more than the number of holes which is present, then at least one pigeonhole will contain two or more pigeons. Equivalently, if there are going to be n objects that are going to be put in m boxes, so we have the criteria n is greater than m, then at least one box will contain two or more objects. So the pigeons are usually kept and reared in boxes like these. So it's natural that each of the box will hold one pigeon if there are going to be sufficient number of pigeons and sufficient number of boxes. But say in the case that there are going to be more pigeons, and so what we can allocate, like each one pigeon can be allocated to one box. But if there are going to be more number of pigeons, then what will happen? Automatically the extra pigeon will be allocated to the same box to which there is going to be one more pigeon, like this case. So there is already one. So there will be a box which has one more pigeon or one or more pigeons when the number of pigeons are going to be more than the number of boxes, okay, or number of holes. So this is going to be the basic structure of pigeonholes. So when the quantity in hand is going to be more than what is going to be available, then we will have to do an extra fitting, like along with the existing one we will have to make a fitting like this, so that two or more of the objects are being squeezed into the same box. So, right, now we will generalize this pigeonhole principle. The statement is exactly the same, like you have n pigeons which are accommodated in m holes and the criteria is n greater than m. Then one of the pigeonhole must contain. So what is going to be the least number of pigeons to be accommodated in any of the hole? So the least number of pigeon to be accommodated in any of the hole is given by the formula floor of n minus 1 by m plus 1 pigeon. So the formula which we are going to use in this session for solving the least amount of object which is accommodative in any of the situations will be n minus 1 divided by m, and then you find the floor of the data. Floor is nothing but this is going to be an function which denotes the greatest integer less than or equal to the value called as x, and then along with it you will have to go with a plus 1. So this is going to be the minimum number I can fill in any of these boxes. There are going to be two cautions in this formula as such if we consider. The first one is, this is a symbol like plus minus division. This floor is also a symbol. So don't replace it with a square bracket. If you replace it, it doesn't have a meaning. Therefore, you will not be given any marks for using these brackets in the formula. So make sure that you have an inverted L and an inverted L that represents the floor of the data. What is going to be floor of the data is, say suppose I have something like 8.325, then what is going to be the integer which is going to be less than or equal to x? This will return me the integer value which is going to be 8 over here. So if I have 5.93 something, so what is going to be the greatest integer value which is less than or equal to x that can be returned will be equal to 5. And that is going to be the first caution. This is going to be an L with an inverted L, the symbol. And the second caution is the bracket inside contains a minus 1 and then there is going to be a +1 which is outside. Usually in exam there will be an quite common confusion whether it is going to be +1 inside and -1 outside. So notice that the formula inside contains a -1 and there is going to be +1 which is going to be outside the full symbol. Okay, so keeping these two cautions in mind, we will move on to solve problems of real time in using this pigeonhole principle. Now the problem number 1 says in a group of 100 people, so it is going to be, let us say 100 million people or 100 people, we will first take it as. Several will have birthdays in the same month. At least how many must have birthdays in the same month? So we have the number of people to be equal to 100. So let me take 100 people. So to start with, okay, so there are going to be many of us celebrating the same birthdays in the same months. Like many of us may have it in the same April month and so on. So how many of us will be having it in the same month? That is, what is going to be the least number of people out of the 100 people who will be celebrating their birthdays in the same months. So now this number of people, which is 100, will be now treated like your pigeons. So they are nothing but my n. So what are going to be the holes? Where are these 100 people accommodated for? These 100 people are now accommodated into holes. What are the holes? Holes are nothing but the months which is available for me. Okay, how many months are there totally? Totally we have 12 months. So we will have to divide it equally as Jan, Feb, March, April, May, June, July, August, September, October, November and December, say. So we have to fill these 100 people according to their birth dates into the corresponding months. So we will have to allocate how many of them are going to have birthdays in November, how many in Jan and so on. So this 12 months which is available for me is going to be my holes, which is going to be treated like m, and we know that the condition for applying pigeonhole is n must be greater than m. So obviously 100 people are going to be more than the number of months, which is going to be 12. Now let us see how many, the least number of people who have their birthdays in the same month is given by n minus 1 by m plus 1. So this now becomes 100 minus 1 divided by 12 plus 1. So it is 99 by 12 plus 1. Okay, so take your calculator, make use of it and find the value of 99 by 12 to be equal to around 8.25. So this will now return me the data as what is going to be the least integer, 8 plus 1, which is there outside. So the final answer is going to be 9. So how many of them will have birthdays in the same month? We will have 9 of the people sharing birthdays in their same month. So 9 in each hole will be the count when I am going to split 100 people for these quantities. So that is going to be the least number of people who share their birthdays in the same month. Moving on to the next problem. What is the minimum number of students, each of whom have to come from the 50 states, who must have enrolled in a university to guarantee that there are at least 100 who come from the same state? Okay, so this is also a similar problem but with an inverse situation. Like we know what are going to be the least number of people who have to be accommodated. The formula is the least number of count is going to be n minus 1 by m plus 1. And now they have said that this value is equal to 100. So what are the remaining quantities that are going to be here? The minimum number of students, the students now act like your pigeons. So what is not known over here is your n. The number of students who need to enroll, that is going to be n, our pigeons, are going to be not known to us. And how many of them come from the state? They are going to be one from the 50 states. Number of holes available are going to be the number of states for me. So how many states are there? They are coming from 50 different states. So this is going to be my m for me. So substituting everything over there in the formula, what happens over here is n minus 1 divided by 50 and plus 1 will be equal to 100. Just cross multiply. N minus 1 by 50 will be equal to 100 minus 1. So 100 minus 1, that makes it as 99. So I want n minus 1, which is there in the numerator. It is going to be the least value. So there will be no harm when you cross multiply this data. This would be 99 times of 50. So your n will be 99 times of 50 plus 1. Use your calculators to estimate this value to be equal to 4951. So I have totally 4951 people to come from 50 different states, so that I can guarantee that at least 100 are from the particular same state. Okay, now we move on to the third problem. A man hiked for 10 hours and covered a total distance of 45 kilometers. It is known that he hiked for 6 kilometers in the first hour and only 3 kilometers in the last hour. So totally he has hiked 10 hours and covered 45 kilometer. First hour he has covered 6 kilometer. Last hour he has covered 3 kilometer. The question is, show that he must have hiked at least 9 kilometers, within a certain period of 2 consecutive hours. It is not just hours. Here they are considering just hours, but when they calculate the least value, what they want is 2 consecutive hours. Consecutive meaning things that happen immediately, one after the other, like integers, like 4, 5. Whenever you have 10, 11. So what are these? 4 and 5 are consecutive integers. 10 and 11 are consecutive integers. So within 2 immediately following integer values, they say they calculate the time period, and in any particular consecutive 2 or time duration, he must have covered at least 9 kilometers. So this is going to be my data for me. Okay, so now let us go with the representation. What is going to be required over here? So this is going to be the total distance he has traveled, and it is going to be 45 kilometers, in which he has covered in 10 hours. Okay, the distance, and this is going to be your time taken. 10 hours now has to be split into equal parts. This is my starting point A and this is my destination B. What he is doing is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are dividing it into 10 equal hours. Now what has happened over here is, in the first hour over here in this duration, he has covered how many units? He has covered in the first hour, he has covered 3 kilometers. And what has happened in the last hour? In this last hour, which is going to be the 10th hour, he has covered how many kilometers? In the first hour he has hiked for 6 kilometers and in the last hour he has hiked for 3 kilometers. So let us first mark the hours over here. So this is the first hour, second, third, 4, 5, 6, 7, 8, 9 and 10. In the first hour he has covered 6 kilometers and in the last hour he has covered 3 kilometers. So these 2 hours to put together, he has covered first and the 10th hour together. He has covered 6 plus 3, which is equal to 9 kilometers. What is the total distance? 45 kilometers. So what is going to be the remaining portion he has to cover between the second to the 9th hour? So remaining distance to be covered will be equal to 45 minus 9. So that is going to be equal to 36 kilometers. This 36 kilometers he has to cover in a duration of how many hours? This is going to be totally out of the 10, 2 have gone, so that is going to be 8 hours. But this 8 hours we are not going to take it as such. What we are going to do is we are going to split it into 2 consecutive hours. So starting from 1, what are going to be the consecutive hour? 2 and 3 will be 1 consecutive hour. 4 and 5 will be next consecutive hour. My 6 and 7 will be the next consecutive hour. And 8 and 9 will be the last consecutive hours. So starting from the point where he has stopped after the first hour, what I am doing is the remaining hours I am breaking it into 2-hour time components. If I am going to break it as 2-hour time components, then how many time slots are available? 1, 2, 3, 4. Okay, so you have 2 consecutive hours to be broken into 4 time slots. So now this 36 kilometer have to be covered in 4 time slots according to the 2 consecutive hour calculation. Okay, now how to go about this? We know the formula is n minus 1 by m plus 1 is going to be the least distance I can cover in any of the 1 time slot. That is, 1 time slot is 2 consecutive hours. So what is going to be n? N is going to be my 36 kilometers, and what is going to be the whole is going to be the time slots over here for me. So 36 minus 1 divided by 4, because that is the whole for me, plus 1. So this is going to be the quantity. 36 minus 1 will be 35 by 4 and plus 1. We know that 32 times you can have to be 8. So this will be around 8.75 and you will have a plus 1. And this can be rounded off to 8 plus 1, which makes it as the value to be equal to 9. Okay, so we have got that he must have hiked at least 9 kilometers in any one time slot. What at this one time slot? That is going to be 2 consecutive hours. So in any one of this particular hours, either in this or in this or in this or in this, what must have happened? He must have hiked for 9 kilometers altogether. So that is how we are able to estimate the minimum distance he would have covered in any of the 2 hours time slots. Okay, so this is going to be something which is going to be more frequently occurring in your examination. So we move on to the next one, and this is something like a construction kind of problem where diagram becomes mandatory. So make sure you have the proper diagram to get the full marks out of it. If we are going to select 10 points in the interior of an equilateral triangle of side 1 unit, show that there must be at least 2 points whose distance apart is going to be less than 1 by 3. Okay, so what we have over here is going to be equilateral triangle. Okay, what do we mean by an equilateral triangle? A triangle who has all the 3 sides to be the same will be called as an equilateral triangle. So I have this triangle A, B, C to be equilateral in nature, meaning that all the 3 sides are going to measure 1, 1, 1 units together. So now inside this point triangle ABC, I need to position 10 points. And how this 10 points have to be positioned? They say that at least 2 points are always a distance of less than 1 by 3 apart. So now I need to make holes to fill these points, because I cannot just like that randomly keep the points. I will have to make holes out of this equilateral triangle. Now the holes which I make must be equal in nature. That is, I cannot make one small hole for one pigeon and one big hole for the other pigeon, and the holes must not be of different geometries. So if there is going to be an equilateral triangle has to be subdivided into sub-equilateral triangle. Sub-equilateral triangle. So I need to know how many holes must be made now. That is, how many sub-equilateral triangles have to be constructed from this one big triangle called as ABC. So I know that this is going to be my 10 points, which is going to be n, and also I know what is going to be the least amount of points to be accommodated in each of the holes. So applying it to the formula which we know, n minus 1 by m plus 1 is given as at least 2 points. So this has been given as 2 for me. So I know that 10 minus 1 by m will be equal to 2 minus 1. So it's just 1. Cross multiply this m. So 10 minus 1 makes it as 9 equal to my m. So I need to make 9 holes so that I am having a space which is going to be comfortable to fill 10 points inside these holes. So I need to construct 9 sub-equilateral triangle. Now comes the construction part. How is that possible for me to equally divide? Because I need to know that each of the hole must be of equal size. So how to equally divide this triangle into 9 sub-triangles? The clue over here has been given that the distance between them is going to be less than 1 by 3. That is 1 by 3, 1/3 of the data or 1/3 of the size. So if the total size is going to be 1, let me divide it into 3 equal parts. Then each of the part will be 1/3 of it. So what do I do is I subdivide this distance into 3 equal parts, 1, 2, 3, so that each part will be 1 by 3, 1 by 3, 1 by 3. Again this side also I divide it into 3 equal parts. So this is going to be 1 by 3, 1 by 3, 1 by 3. Here also I am going to subdivide it into 3 equal parts. So this is 1 by 3, 1 by 3, 1 by 3. Now what is the next stage is you start connecting. This is A, B, C. Let me mark it as D, E, F, G, H, I. What I am going to do is connect D and H. Next connect H and your E. Now mark this middle point of your E and H so that this will also be 1/3 of it. Okay, now connect this and this. So I have the triangles generated. Now connect E with F and now with this middle point and again with G and again with your H. Okay, now we are done with the construction. Now the magic is you will be having 1, 2, 3, 4, 5, 6, 7, 8, 9. So exactly 9 sub-equilateral triangles have been generated. So we have completed the construction part of it. I have generated 9 equilateral triangle. Now the point is that I need to place the 10 points within this equilateral triangle. So we will see how to do about it. So I have this equilateral triangle. Now I am placing point 1 over here. I have 10 points. First point, second point, third point, fourth point, fifth point, sixth point, seventh point, eighth point, ninth point. Totally how many points were there? 10 points. And the theorem also showed that we will have to have 2 points in one sub-equilateral triangle. One of the sub-triangle must contain 2 points. So what will happen is 10th point have to be positioned somewhere along with the existing one. Okay, now so let me place the 10th point along with this 9th point. So let me consider this small triangle over here, which is going to be H, F and G. So now this small triangle is going to be of having a side of length. What will be the length? Now I know each of them are going to be 1 by 3. So this will be 1 by 3, this will be 1 by 3. So this will be 1 by 3, 1 by 3, 1 by 3 everywhere. So this equilateral triangle has a side to be equal to 1 by 3. Now if 2 points are positioned, where maximum I can position the maximum distance, I can position the points for the 9th point. If I keep here, the 10th point I can keep it over here. A 9th point is here, mean maximum distance is 10th point, I can keep it over here. Wherever you move, we can see that the maximum distance is going to be just 1 by 3 since it is going to be an equilateral triangle. So we say that the maximum distance apart for any of the 2 points which have been placed together by the pigeon hole will not exceed or will always be less than 1 by 3. So this is going to be the case when I am going to consider the 2 points which will be less than 1 by 3 from each apart. Now we move on to the next problem. If there are going to be 5 points inside a square of side length 2, prove that 2 of the points are within a distance of root 2 from each other. So now I am going to have a square. So I have a square. What is the nature of the square? The square is going to be of side to be equal to 2 units. Now I have 2 units everywhere, and now I need to place 5 points over there, and at least 2 of the points must be in the same one. So n minus 1 by m plus 1 is going to be equal to 2, and I know that this n is going to be equal to 5. So 5 minus 1 by m will be equal to 1, and so my 5 minus 1 will be equal to m, and my m will be equal to 4. I need to subdivide the square into 4 equal parts. How can I do 4 equal parts? Okay, now we will go with the splitting it into 2 equal parts each of the sides, so that if I am going to draw the line over here, I will have 4 equal parts of subsquares. And now this is going to be one of the subsquares for me. So this is going to be one of the subsquares for me. And if I am going to take this subsquare, what is going to be the length of the subsquare? The length of the subsquare will be equal to, this will be 1, 1, 1, 1, 1, 1 everywhere. Okay, so this will be of 1, this will be of 1. Now what happens if I am going to place the points, the first point over here, second point, third point, fourth point, the fifth point has to be placed along with one of the existing ones. So if I am going to place the first point here, what is the maximum distance I can cover is going to be over here. So the maximum distance of any square happens along its diagonal. So what will be the distance of the fifth point from that of the first point? So for the triangle along the diagonal, what will be the value for the diagonal? This is 1 and 1, so this will be root over 1 square plus 1 square using our Pythagoras theorem, and hence this will be equal to root 2. Hence we have got that the 2 points over here which are placed inside the same box cannot be more than that of root 2 from each other. The maximum distance can only be root 2 if it is going to be placed in the same box. So that is going to be the concept over here. We move on with the last one. There are going to be 5 points chosen in an equilateral triangle. So again we have an equilateral triangle. The point is that the side is going to be equal to 1 unit as our first construction problem, but we have only 5 points. So how many holes we need to make? If it is 5 points, I need to make 4 holes. Now I need to make 4 equal subequilateral triangles from here, and it is of ½ inch each from each other. So what do I do is I split this into 2 equal parts. Half means 2 equal parts, so that this becomes half, this becomes half, 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 half. So what will be the construction for it? The construction part will be connect this, connect this, connect this. So I will have 0.1, 0.2, 0.3, 0.4 and 0.5. If I am going to place anywhere inside it, the distance will obviously be less than 1 by 2, which is going to be the side of it. So I hope that this pigeon hole principle has given you an wonderful insight on how to position the least number of objects that can be accommodated in any particular position. Okay, happy learning, continue learning. Thank you very much.